Hello. What I'm going to talk about today is I'm going to go through some of the latest advances in robotics and how it's just about beginning to become a really hot area, how we need to start getting on board and making sure that Britain doesn't get left behind in what's going to be going on. And then towards the end, I'm going to be introducing some new educational tools and resources for bringing this stuff into schools, motivating kids to become engineers and scientists, and getting on board with the new computer science curriculum. Is that kind of what you've come to listen to? So nobody's surprised or thinking they're in the wrong place. So if we could just start off, if I could have a show of hands. How many of you here teach computer science? Yep, put your hand up. Okay. How many teach ICT? Great, so you're trying to manage the transition. Who's happy today with the teaching resources for teaching computer science? You're happy? Happy? Anybody? No, you're not. So you'd be interested in some better resources. Well, that's lucky because I'm going to show you some great resources. Just one other question. Who's seen the film Terminator? Hands up. Okay. So you know what I'm talking about when I mention Skynet. Yeah? Okay. If you don't know what, you're going to find out soon in this talk. I was invited by that big smiley chap, Chris Burgess. He's on the stand just out there, B79. He's together a business for creating these education kits and online training materials for making it easy to take on board the new computer science curriculum and for motivating the kids. Now, I'm not affiliated to Chris at all or his company, but he used to work with me designing robots at how he can get kids all the way down to primary experimenting with doing some of this stuff. Example of one of the robots that we developed probably about 8 years ago for the MOD. It was called Testudo. It was man portable, and Chris was very instrumental in creating that machine. Now, you're not going to be able to do that with the educational kits, but I think it will lay the foundations and really get people thinking along those ways. But let's just take a step back. The promise of robots. I mean, we've all read countless science fiction films. They're going to be helping us doing space exploration, looking after the elderly, handicapped, domestic help around the house. Manufacturing. We can't afford to do manufacturing in this country at the moment. We've let it all go to China. However, if you had flexible robots, that could come back. That creates loads of jobs in industry. So what's gone wrong? Why haven't we got... We've been talking about robots for so long. Why haven't we got them? Now, if I can step back, when I started out, I did computer science, and then I moved into British Aerospace. And back then, in the early 80s, we were on a kind of wave of optimism. Computers just seemed to be cracking problem after problem. You had Doug Lenat, who got computers making mathematical discoveries, Goldbach's conjecture. You had Claude Shannon, the father of information theory, and he was programming chess. Wow, chess is hard. Surely if a computer can do chess, it can help at least, or something like that. When I first started looking at computer image processing, it was a very naive approach back then. You know, people approached it from a very logical point of view, trying to analyze edge junctions and things like that and say, well, that's the corner of a cube. But the world isn't a blocks world. It's much, much harder than that. And actually, what we found back then in the 70s and early 80s was computers were great at what we're bad at, which is doing logic and things like that, and they're not good at perceiving the world, at learning, in the presence of noise and ambiguity, at controlling to climb a ladder, balancing, restoration, if somebody kicks you over, common sense. They're hopeless at common sense. And natural language. Things that every 6-year-old can do, but defeat the world's cleverest computers. And when I was working on doing missile guidance systems back then, I suddenly just got an inkling of how clever we are and how hard these problems are. And I was quite deflated at the time because I thought, God, that's an awful lot of work that we've got to actually do. I started off at BAE Systems in Filton, Bristol. And just to give you an example, just take that part of the image, zoom in, and this is the level at what you're looking at things in a computer, trying to make sense of those pixels and decode it so you understand the structure of the world. I think is just one of the greatest feats that we do effortlessly all the time. Here's some work that I actually did. I did some software that could process natural scenes, and it would analyze the textures and actually classify, and it would say that's sky, roof, trees, ground and building. And it may not seem very much because we can all do that all the time, except back then it took 1 hour to process one picture on a VAX computer, which was really expensive machines back then. Anyway, I then went into the automotive industry, slightly disheartened with defense and all the kind of problems that we're solving. I actually joined Lucas Industries, and I ended up running a site that's just about 5 miles from here in Shirley. It's the Dog Kennel Lane. It's now been bought by TRW, but I run that engineering site, and one of the big gripes that I had at the time was, how do we get more engineers, more people to want to do that, rather than go to trading rooms or whatever. And I think it starts with schools. I mean, I love this stuff. When TRW bought us, TRW, they made the lunar lander. They made the Viking spacecraft. My boss back then, who was the chief technology officer, was the Apollo 13 mission controller. The stories he had was just absolutely amazing. I mean, he was telling me when they were, when the craft was coming around the side of the moon, if it had been 1 second earlier, they would have missed the Earth by 1,000 miles one way. 1 second late, they would have missed the Earth by 1,000 miles the other way. They had 10,000 people problem solving, because they had to make decisions before they'd worked out all the implications. So you would set up tiger teams. Well, if the world goes this way, start thinking about that. If the world goes that way, start thinking about that. We hardly had computers back then. So it was a very exciting time. But one of the projects that I did back then was I led a project to create an autonomous car. This was back in 1994. We did it with Jaguar and with Oxford University, Cambridge and Southampton University. That's a very youthful me driving the car. It had a video camera on it which would reckon, this is the M42 in fact, that used to be our test track back then. Things have tightened up a little bit. And then we had a 76 gigahertz radar that could measure the distance and the relative velocity to about 25 cars in front. And on the car, you just pressed the lane guidance button and it would steer, it would brake, it would control the throttle. And back in 1994. Now out of that, we had a number of spin-off products. So we had, for instance, adaptive cruise control. That's on the market now. Lane warning. It's on Citroen, for instance. That's on the market. I'm still waiting for the day when they allow the hands-free. But interesting, if you have hands-free driving, you can now have traffic control, and you can have it, like, for instance, where the junction, the cars don't have to slow down. So they go past. So you could really increase the capacity of the road. Lots of exciting stuff like that. When I set up my own company in 2003, I specialised in creating new product concepts. And this is something we did, this bad boy here was something we did for the MOD for detecting explosive devices and also for surveillance. So Chris was a big part of this. It's man-portable, you could carry it in your backpack. It had a top speed of 35 miles per hour, it was about that size, and that was so you could evade pedestrians who might try and catch it. It had an inertial navigation system and GPS, so you could program in GPS waypoints and it would automatically follow it. You had sonar, so you could avoid obstacles. IR motion sensor, and then it had a camera with a 50 times zoom. So it's pretty cool. But what we implemented on there was a sort of behavioural-driven architecture that made it very easy for programming this device. It was kind of made up as layers of behaviours. This was inspired by a guy, Rodney Brooks at MIT, who was kind of used to study natural behaviour. How do people do this? How do insects do it? And a lot of this stuff has got into these Mars rovers and so on. But basically, the top behaviour was you follow the mission, the GPS waypoints, unless the battery's running low, and then it returns home. So that then takes priority, unless there's an obstacle in the way, and then you go into obstacle avoidance. So this robot was never at a loss what to do. It always had something, and you could have another behaviour that would be just explore the world if nobody's given you anything to do and there's no obstacles in the way. It was a really easy way of programming in layers, because this is what we want kids doing. But it's not just the work that we did. This is some amazing work. I worked with Roke Manor, and this is structure that they've inferred purely from black and white computer imagery. So things like using the motion of the camera, parallax, tells you how far away things are. And from that, you can build up all the structure in the image. This is massive. I mean, this is what people do. And we're so good at it. You know, the structure, we don't have an active rangefinder, we don't have a radar, and yet our very dodgy perception, we trust our lives to it. We'll happily run down the side of a mountain, perfectly placing our feet and priming our muscles in exactly the right place, just because of the sense that we've made of a whole bunch of colours and shades of grey. It's an incredible feat, but now computers are beginning to do that stuff. And they're beginning to do it quite well, and they're building it into focus machines in cameras and things like that. This was some algorithms that we developed, which was for threat detection. Now it's interesting, which do you think is the most hostile threat when you look at those things? That is. Not that. That can only kill one person. This person could have a mobile phone saying they're coming and detonate a bomb. But what's the difference between this hostile behaviour and this innocent civilian behaviour? These were some of the things that we were trying to detect, so that when troops come into towns, they kind of can gather intelligence before they arrive as to what's going on there. So these algorithms were sort of doing that. In 2011, IBM created a computer called Watson, which they entered into a game show called Jeopardy. Now, Watson wasn't allowed to be connected to the internet. It They downloaded all the pages of Wikipedia. And Watson's reasoning, when the question was asked, would parse it, look at the natural language, read the right, look through Wikipedia, and then reason what was the right answer to give purely from Wikipedia. Watson beat 2 contestants who were past winners to win $1 million on the game show. That is just absolutely amazing. So now these are sort of higher level cognitive tasks that are actually going on. Control, this is just amazing what people have been doing recently. This is a company called Boston Dynamics that's massively, can we turn the volume up? It's massively funded by the US Army. That would just scare the living daylights out of you. Can run at 28 miles per hour. Cheetah, it's called. Watch out who's saying the call. So much clever control to be able to do that. Frightening. However, we've still got a long way to go. I mean, here's an interesting thing. Google still finds natural language hard. So, what fruit is squidgy like an orange? I would expect it to come back with, well, a grape is a little bit squidgier, a lemon, kind of fairly similar, perhaps a bit firmer. What's this, a chocolate fruitcake recipe? It doesn't know what I'm talking about. Or squidgy vitamins from Asda. Google has no idea what you mean when you type things into it. And they know that. Now, natural language, it's a kind of shorthand between us because it only works because we've both experienced the world, the physics in the world. It's a shorthand. I don't need to tell you that it hurts to fall off a ladder. You already know that. You've done that or whatever. Google doesn't know that. And its intelligence is greatly impoverished as a result of that. But what's interesting is they now want to change that. They now want to start instrumenting robots that can feel the world, can correlate what an orange feels like when you squeeze it, what it tastes like, what it looks like on your retina, and correlate all that information with their database. So they're much more in touch with how the world works. And what's interesting, over the last year, because they've got more money than God, they've bought 8 robot companies, including Boston Dynamics that you saw in that video. So Google takes this really seriously. They've just hired a guy called Ray Kurzweil, one of the pioneers of computer science, to basically give them natural language, to really get them up that speed, up that curve. So Google is positioning itself to become the world's #1 artificial intelligence company. There was a British computer scientist in 1965 who talked about an amazing landmark in history. The point when humans make an intelligent machine that can also make a copy of itself, but a tad more clever. And that he called the intelligence singularity, when machine intelligence will leapfrog ahead. Because one machine will make another machine that's a bit cleverer, that will make another machine that's a bit cleverer, that will make another machine. That's what Google wants to do. And that is kind of why it's scary, Skynet in Terminator, because we are racing headlong towards that world right at the moment. So in a few years, it's going to look like that. So can't we do something, are we going to leave Google to have all the fun? Isn't there some rival? Can't we marshal our intellect? We pioneered the computer revolution. Come on, let's do that on robots. And maybe set up a rival, perhaps, I don't know, Michael GoveNet or whatever. My belief is robots are going to be as big as automotive. It's got mechanical engineering, it's got software programming, it's got everything. But the thing is, we need more engineers and scientists. It's something that I complained about enormously when I used to run engineering centres. But also, particular skill, we need system integration skills to pull all these technologies together to make it work. It's going to happen with or without us. You can't put it back in the box once it started coming out. And I think it just starts with motivating children to want to go and do this stuff. And that starts in schools. But what we need is a practical approach. My understanding of teachers is they are absolutely overwhelmed with all the number of initiatives that they're trying to do. There's only something like 30% of your time is now with kids. I don't know, is that right? Hands up if that's correct. No, it's more than 30%, is it? Okay, that's an exaggeration or whatever. But I think practical approaches for getting this stuff into schools. I think we had a lost generation where schools were teaching Microsoft Office. You don't go to school to learn Microsoft Office. You just switch on a computer and you do it. You go to school to learn how to program, the fundamentals behind computer science. So that's something that I think is important. And that's really why I'm giving this talk, because I greatly admire Chris Burgess and what he's trying to do with his CBIS education kits. So what he's done He's trying to make it easy to take on board the new computer science curriculum, and he's put together an array of resources that hopefully will bring us up to the forefront. So there's a robot kit. It's very easy to assemble. It's got a Raspberry Pi processor, and then it's got a number of resources, so you can program it. You can help primary kids programming in Scratch, for instance, which is a nice visual programming language, all the way up to programming in Python or whatever. There's a remote control car as an alternative, with some of the ideas that Chris got from the defence work that he used to do with me, with lots of resources around real-world applications and so on. Really cool, and I don't know if you've had a go on it yet, but there's what he calls the Jedi headset. This is something you put on your head, and it can detect the electrical signals in your brain. Now those signals you can feed into the Raspberry Pi over the Wi-Fi, and you can program things to do. So you can learn to think and push the robot arm, for instance, purely by thought. Or, if you were a very handicapped kid or whatever, it is another way of you actuating things and controlling the world, which is kind of really important. But it's another kit in the armory of these resources. But I guess the biggest thing on it all is the online virtual learning environment that's done in Moodle. And really this is aimed at the teachers themselves. Trying to get the teachers ahead of where the kids are, so that actually they've got control over the classroom and they can sort of control things. So it's got resources in there for lesson planning. It's got reference material on all the parts and all the different programming constructions and so on. It's got it pitched at different age groups, and it's all laid out with a very easy roadmap which you follow, so that you actually are in charge of the curriculum, and very productively you can pull together your own lesson plans and get ahead. Now, if you think this makes sense in your schools, I've got a discount form that Chris has produced. It's basically 15% off all the kits. He's got them on the stands. I think he's brought about 100 of them. They last for 2 months. So if you want to get these kind of resources into your school, fill out the form and then lodge it there, and then you've got a couple of months to mull over it and talk with it through with the head of your department or head teacher or whatever to sort of make it happen. Also, I've filmed this presentation, so that will also be on the website, so that you can go through this with your colleagues offline and actually decide if this is the way forward. Thank you. Are there any questions?